Hello everyone, my name is Polat, your name is Mehmet. Today I will talk about the Fundamental Theorem of Calculus, which includes two parts, and I will give the explanation of two parts, and I will give some examples about it to understand the topic better. Finally, I will give the proof of them. Let's begin. If we want to understand the Fundamental Theorem of Calculus, we have to know three conditions in this theorem. First condition is that our ft is continuous on A and B. And our second condition is the integral of our function from a to x is also continuous in A and B. Yes? And our third condition is the derivative of the integral of our function from a to x is also existing in the interval of a and b. The derivative of this function, which is derivative of integral from a to x, and our function is ft dt, exists in a and b. If you see these conditions, you will get this formula. Derivative of x is equal to the derivative of integral of a to x ft is equal to just fx. Let me give you some examples to understand. And I will keep this formula here, because finally I will give the proof and we will reach this point. Okay? So, example 1. Find the derivative of integral of t cube from 4 to x. You look and you see in here x, yes? And the instruction asks you to find the derivative of this integral, yes? And you see that your function is given with another variable t. Automatically you substitute x with t and you just write x cubed. That's it. That's the answer. Second example. Find the derivative of this integral from 5 to x and t squared minus 4 dt. Again, you see in here x, yes? You see that your function is given with another variable t. And you see that instruction asks you to find the derivative of this integral. Again, you automatically substitute x with t, and you will get x squared minus 4. That's it. And let me give you the proof of it. What is the proof? To prove it, we have to just draw the diagram, graph. It is our function ft. And as you see, our function ft is continuous in the interval a and b. Yes? Which is our condition. So, what was our fx? Our fx is equal to integral of a to x ft dt. And what is our derivative of x? Derivative of integral from a to x ft and dt. From previous lesson, from the definition of derivative, you know that we can write this derivative of fx, with this formula. Fx plus h minus fx divided by h. Yes? And we have a limit in here also. Limit h is going to 0. Yes? We can write this as this way. So, if we put x plus h and x instead of this x, we will get this formula, new formula, which I write with another color. Our fx is equal to, we just substitute with that, okay, with this x. Integral from a to x plus h ft minus integral from a to x ft divided by h, and we have also limit in here. Limit h is approaching to 0. we get this formula, yes? Let's draw this formula in this graph, okay? So, let's draw x and x plus h, yes? What is the, answer of this formula? The answer of this formula, if you solve according to the integral equations, you will get this point. You will get this. Limit h is approaching to 0. Integral from x to x plus h, because our bases are same. Ft multiply 1 over h, because we cannot actually simplify h with something. And what does it mean? It is just actually the area of this region. Yes, it is the area of this region. You have to know this right now. And keep this formula in your mind. Okay? Now I will write another theorem. Mean value theorem. You know mean value theorem? What does it say? It says that C is existing in the interval x plus h. What does it mean? It means that we have C in this region, and this is our FC. As I said, it is area, yes, in this formula. How you can find the area of this region, with another formula? This is rectangle, yes? You can find with multiplying width to height, yes? What is our width? Our width is equal to x plus h minus x, yes? As you see here. And our width is h. And our length is, our height actually, is FC. And again, let's write the area. What is the area? Actually, the definition of integral in another word is area, yes? Fx, again I'm writing the same formula. The derivative a to x ft dt. What we got from this formula? We got that x plus h, yes? And we put the c according to mean value theorem, and what we get fc multiply h, yes? We got that point. We got this formula, yes? And actually, from now, you can actually simplify these two sides, yes? Divide this to h and h. What will you get? You get multiply 1 over h and fc. You got that derivative of fx is equal to fc. Derivative of fx is equal to, we have also limit in here. Sorry, limit h is going to 0. I'm sorry. Fx is equal to limit h is going to 0 fs. Limit h is going to 0 fc, yes? And if you see that if h is going to 0 in here, our c will also squeeze to the x value, yes? And it means that if h is going to 0, our c is going to x. And our fc normally will approaching to fx. That's it. This is the final formula. Okay, now our second part is Fundamental Theorem of Calculus 2. Actually, it says that from A to B, ft dt is equal to fb minus fa. Okay, how we can prove this? We can prove this like that. Let's write another integration from a to x. Ft dt is equal to, from ordinary integration, you know that it's equal to fx plus c. And also you know this from Fundamental Theorem of Calculus part 1. Yes. Now we can substitute this x with a. We will just write in here a and here a. What we will get? We will get integral a to a ft dt is equal to fa plus c. What does it mean? It means that we have only this variable a, and the area in here is 0, as you see. There is no area. That's why fa plus c is equal to 0. And c is equal to minus fa. Yes? And let's substitute c in here. What we will get from a to x, ft dt is equal to fx minus fa. You see, we got the formula. AB, fb minus fa, and here ax, fx minus fa. There is nothing special. It can be c, it can be b, whatever you want, okay? So, that's it, guys. It is the fundamental theorem of calculus. It has 2 parts, and I explained both of them, and I give you the proofs of them. And there are some examples also. You can solve it. For example, derivative of 0, 4, and t squared. The integral is equal to this, as you see, t cubed over 3, and 4, 0. It means that first you will put 4 instead of t, and second you will put 0 instead of t, and you will just minus. So it means that 4 cubed is equal to 64 over 3, minus 0's cube is also 0, minus 3. And our answer will be this. Okay, that's it. Thank you for listening. Goodbye.